In section 3.3, we'll be discussing implicit differentiation. So far, we've looked at functions that are expressed in an explicit form. That means we can see explicitly which variable is independent and which one is dependent. Usually that means that this is solved for y. So now we'll look at implicit form, and that means it's not solved for y. And so it's just the relationship between your independent and dependent variables is implied. So if you think about the English word implicit, it just means implied, and so that relationship is implied there, whereas here it's explicitly solved for y. So pay attention to these two different types of functions. If I see an implicitly written equation, if I want to find the derivative, I will have to use implicit differentiation. And so what you want to pay attention to is that dy dx, that means the derivative of y with respect to x. So actually, I'm going to just highlight this denominator here. That's the variable, that's my independent variable. And so I'm taking the derivative with respect to x. And so that means if I differentiate terms with x alone, I just take the derivative like normal. But if I differentiate any terms involving y is actually acting like a function then. And so when I take the derivative of a function, I have to apply the chain rule there. So essentially when the variable doesn't match up with whatever variables in the denominator of your derivative, you will have to use this implicit differentiation. So let's see what that looks like. So here I'm taking the derivative with respect to x of x cubed. That matches, so I can just take the derivative like normal. That's 3x squared. But in part B, I'm taking the derivative with respect to x of y cubed. So notice those are two different variables. When I take that derivative, then I'm going to treat y as its own part of a function. And so I'm going to use chain rule. And so this will look just like 3y squared. So far it seems the same, except now I'm going to need to multiply by the derivative of the inside, and the inside is y, so the derivative of that is dy dx. So whenever I'm taking the derivative of something with a y, I will just have to multiply by dy dx. That's the derivative of the inside. So I'm treating y as its own function. In C, I have the derivative with respect to x of x plus y. So I see the first variable there matches up. The second variable does not. So when I take the derivative with respect to x of x, that's just 1. But when I take the derivative with respect to x of y, that is 1 times dy dx. In other words, we just have 1 plus dy dx. And that's our answer. For part D, we have the derivative with respect to x of x times y squared. So again, let's pay attention. Taking the derivative with respect to x, I have an x and I have a y. So here, since these are being multiplied, I will have to use the product rule. So take the derivative of the first part, the derivative of x is 1 times y squared plus x times the derivative of y squared is 2y. And then remember, since the variables don't match, I'm going to have to multiply by dy dx. We can simplify this just a little bit. Y squared plus 2xy dy dx. And that will be our derivative. One thing you can do to check your work is however many y's you have in your function, when you take the derivative, that's how many dy dx's you should have. So I see 1 y here, so I have 1 dy dx. Here are some steps for implicit differentiation that will help you keep track. So first, you're going to differentiate both sides of the equation with respect to x. Usually it's with respect to x. That variable could change, but it is generally with respect to x. Remember, you're just paying attention to the denominator there of that derivative. So then you're going to move all of your terms with a dy dx on the left side of the equation, everything else to the right side. So everything with a dy dx on the left, everything else to the right. You're going to factor out dy dx, and then you'll solve by dividing both sides of the equation by the factor that does not contain the dy dx. Okay, so in number 1, we have, it says to find dy dx, given that y cubed plus y squared minus 5y minus x squared equals -4. We recognize that this is not solved for y. I have a mix of variables here. I have y's and x's. That tells me I have to use implicit differentiation. So step 1, I'm going to take the derivative of both sides with respect to x. So the derivative of y cubed is 3y squared, but since that's a y, I'm going to have to multiply by dy dx. Plus the derivative of y squared is 2y times the derivative of y, dy dx, minus 5y, so the derivative of that is minus 5 times the derivative of y, dy dx. And then we have minus x squared, the derivative of that is minus 2x. Now you could, if you keep on this trend, we would multiply by dx, but that's just 1. The derivative of x with respect to x is just 1. So it doesn't need that other part. On the right side, we have the derivative of -4. That is 0. So make sure you actually take the derivative of both sides. Double check here. Do the number of dy dx's match the number of y's? I have 1, 2, 3, and I had 1, 2, 3 y's in my original equation. So that seems to be set up okay. Step 2 was to collect everything with a dy dx on the left side and everything else on the right. So I have a dy dx here, here, and here. All of those terms are going to stay on the left side. My 2x does not have a dy dx, and so that will go to the right side. So I have 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. Step 3 is to factor out your dy dx. So I see that common dy dx again here in each of those terms, so I can factor it out in front or in back, whatever you prefer. And then the coefficients there will become their own terms. So I have 3y squared plus 2y minus 5, and that's equal to 2x. Our goal when we're finding the derivative is to solve for dy dx. And so what we're going to do now to get this dy dx by itself is to divide both sides by this polynomial. So step 4, dy dx is equal to 2x divided by 3y squared plus 2y minus 5. And that is our final answer. In general, if your original function is implicitly defined, so it has x's and y's on both sides, your derivative will be as well. So you'll see these derivatives with x's and y's in them. Okay, so for these problems, we'll do the same thing. So number 2, we have y squared equals 2x plus 3y. So, and we're taking the derivative with respect to x. So pay attention, it says find dy dx. So the derivative of y squared is 2y times dy dx. On the right side, I have the derivative of 2x, that's 2, plus 3 times the derivative of y, which is dy dx. I had 2 y's, I have 2 dy dx's. Now I need to move my dy dx's to the left side. I see this 3 dy dx needs to move over to the left. So I have 2y dy dx minus 3 dy dx equals 2. My next step is to factor out my dy dx. So if we do that, we'd have 2y minus 3 times dy dx equals 2, what was left on the right side. And my last step is to divide, so dy dx equals 2 over 2y minus 3. Number 3, we have 2x plus e to the y equals x squared minus y squared. So when we take the derivative of 2x is just 2. The derivative of e to the y, this is our chain rule version of the derivative of e to the x or e to the y. So that's just e to the y, the same thing, but then I multiply by the derivative of my exponent. And the derivative of y is dy dx. So don't get worried just because you see an e in this problem. It doesn't make it really hard. Derivative of x squared is 2x. The derivative of minus y squared is minus 2y times dy dx. Double check, I had 2 y's in my original equation. I have 2 dy dx's. Okay, so next we're going to collect all of our dy dx's on the left side. So I have this e to the y dy dx, that's going to stay there. I'm going to move this 2y dy dx to the left side. This 2 will need to go to the right side. So I have e to the y dy dx plus 2y dy dx, make sure you actually change that sign, equals 2x, and then I'm going to subtract this 2 to move it to the right side. Next step is to factor e to the y plus 2y dy dx equals 2x minus 2. So dy dx is 2x minus 2 over e to the y plus 2y. In number 4, we have 2xy equals 3y squared plus 2x. Where most people are going to make a mistake is in this 2xy part. What you have to realize is the x and the y are being multiplied together. And so we have the 2x part and we have the y part. And so what that means is we're going to have to use the product rule there. If you look at the right side, we have separate terms for the y and the x. We don't have to use the product rule on that side. Okay, so we've got the 2x and we have the y. Those are our 2 parts. My colors are overlapping there. Sorry, it might make it more confusing. So I take the derivative of 2x first. The derivative of 2x is 2 times the second part y plus my first part 2x times the derivative of y, which is dy dx. Now I know that might get confusing. Your dy dx is not always attached to the y, okay? So it's where you take the derivative of the y is where the dy dx goes. Equals, on the right side, the derivative of 3y squared is 6y times dy dx, plus the derivative of 2x is just plus 2. After this, it's the same as before, so I move everything with the dy dx to the left side, everything else to the right side. So I have 2x dy dx minus 6y dy dx equals 2 minus 2y. Factor now, 2x minus 6y dy dx equals 2 minus 2y. And finally, we're going to divide. So dy dx is 2 minus 2y over 2x minus 6y. So this is perfectly fine for a free response question, but on a multiple choice it might be simplified. We can see that we could actually divide each of the terms by 2. So 1 minus y over x minus 3y. You might also see this, though, as the opposite signs in both the numerator and denominator. And that would have come from just moving my dy dx's to the right side instead of the left side. And so don't be worried if you don't see this automatically on a multiple choice problem. You would just know that you would change the signs on each of the terms. So that would become y minus 1 over 3y minus x. Again, you don't need to do that unless you're trying to match up on a multiple choice. Otherwise, I would leave it right here. Don't even worry about simplifying it. All right, number 5. We have 5x cubed plus 3 equals 2y minus 3x squared y. So I've got, in this last term here, notice again we have multiplication. So I've got minus 3x squared, and I have y. So I have to use the product rule again there. So the derivative of 5x cubed is 15x squared. The derivative of 3 is just 0, so that goes away. The derivative of 2y is 2 dy dx. Now for the product rule. I take the derivative of minus 3x squared first. That's minus 6x, still times the y. And then minus 3x squared times the derivative of y, which is dy dx. So again, in this case, the dy dx is not attached to the y. It goes wherever you were taking the derivative of y. Double check, I had 2 y's to begin with, 2y, and the y there, I have 2 dy dx's. Now it's up to you in this case. I could move all my dy dx's over to the left side, but they're already all on the right side. So why don't we move the other terms over? It might feel a little bit backwards, but I think it will be easier. So I'm going to add the 6xy to the left side. 15x squared plus 6xy equals 2 dy dx minus 3x squared dy dx. Again, I just decided to keep them all on the right side because they were already on the same side together. Next we factor 2 minus 3x squared dy dx. And then I'm getting the dy dx by itself, so I'm going to divide by 2 minus 3x squared. So I have 15x squared plus 6xy all over 2 minus 3x squared.